Welcome to another video from explainingcomputers.com. This time we're going to take a look at this, the Milk-V Jupiter 2. This is one of the first computers with an RVA23 compliant RISC-V system on a chip. RVA23 is a standard for RISC-V processors able to run the same software, and so this is an important step forward towards end-user RISC-V systems that can provide an alternative to ARM and x86. So let's go and take a closer look. Right, here we have our Milk-V Jupiter 2, and specifically a model with 8GB of RAM and 128GB of UFS onboard storage. I ordered this from A-Race in May 2026 for $250.86, having bought a $5 code in February for a $50 discount. And I also paid about $90 in shipping and import duties. This said, giving you prices is getting pretty meaningless for any product that includes RAM and flash storage. So let's open this up. Let's bring in Stanley the knife. I think we just have to cut, I think it's just here and here, if I got it right. Will that let us in? It will. And oh look, it's boxed inside the box. I didn't know that. There we are, we got box in box. Get rid of that. This has got some of that stuff on, clean filmy stuff. Let's get rid of that too. Oh, this is exciting. I always like a new SBC, especially a RISC-V SBC. There we are, got into that too. And then presumably, I think it comes up here. Or is it a box? It's a box. And here we are. It's coming out. Unusually for this channel, what we have here is not just an SBC, but an SBC that comes in a case, a metal case, which I can't get the packaging off. How does the packaging come off the case? I'm sure I can do it. Well, that's one way to do it. I've got it off, and let's take a closer look at our box, which is probably more exciting around the back, isn't it, where we can see all the connectors, including the connections here for these antennae, which were included in the packaging. This said, I'm sure we really all want to see inside, so let's use the magic of filmmaking to achieve that. And there we are, I've performed some significant disassembly. The form factor of this board is Pico ITX, and the processor is a Spacemit K3 here under this very large active heatsink. And let's just turn the board over, shall we? Have a look at it underneath. There we are, our first RISC-V computer with an RVA23 compliant processor. However, before we leap into specs and testing, I want to stress that this is development hardware for RISC-V pioneers and possible industrial use, and is absolutely not a consumer product. So, whilst we will be comparing this to ARM and x86, right now, if you want to buy an SBC or mini PC for general computing, RISC-V is not a sensible option. But it will be in the future due to pioneering hardware like this. It's also worth noting that the Milk-V Jupiter 2 is one of several virtually identical Spacemit K3 Pico ITX SBCs that are just becoming available, with others including boards from Banana Pi, Cyped and Spacemit themselves. But I'm now the proud owner of this Milk-V Jupiter 2, and I'm not planning on testing hardware based on the same reference design from other manufacturers. So here we have our board with its cooler removed, and if we turn it over, we can see its Spacemit K3 system on a chip. This has 8 Spacemit X100 CPU cores clocked at up to 2.4 GHz. In addition, there are another 8 A100 NPU cores providing up to 60 TOPS of AI performance. And the K3 also has an Imagination IMG BX M464 MC1 GPU. Additionally, on this side of the board we have a 4-pin CPU fan connector, as well as our RAM and flash storage. Here, this is 8 GB of 6400 LPDDR5 and 128 GB of UFS 2.2. But boards with 16 and 32 GB of RAM and 256 GB UFS are also available. If we flip board back over like that, we can see that there's a wireless module offering Wi-Fi 6 and Bluetooth 5.2. There's also a nano SIM slot to support 4G or 5G connectivity if an appropriate card is fitted in this B-keyed PCIe 3.0 2-lane 2242 or 3042 M.2 slot. Talking of which, we also have this 2280 M-keyed M.2 slot, which can take an NVMe SSD. This slot is PCIe 3.0 4-lane if no other PCIe card is fitted, but drops to 2-lane if there's a PCIe card in the other slot. Turning to the main long edge, we start with a USB Type-C connector. That's the way to power the board when fitted in the supplied case. Bizarrely, this port also provides the only means of connecting a monitor, as it includes DisplayPort Out mode supporting up to 4K at 60 frames a second. This means that it's possible to power the board from a monitor connected via a single cable to this port. But in most scenarios, a hub will have to be connected to use it for both power in and monitor out, which in my view is a crazy design choice. And when we test out the board, I'll be using this powered USB-C hub and this 65-watt USB-C power adapter. Back on the main connector edge, we also find a second USB-C port, which is OTG for flashing an operating system to the UFS, and which also supports a standard data connection. We then have 4 Type A USB 2 ports and an RJ45 connector for gigabit Ethernet. Finally, on the end, there's an enhanced small form factor pluggable or SFP Plus port. This is not something I've seen on an SBC before and can provide a 10 gigabit optical or Ethernet network connection when used with an appropriate cable or modular transceiver. Spinning 90, on the next edge there are 36 and 26 pin FPC I/O connectors. These are a bit like the GPIO pins on other SBCs, as they provide UART, PWM, SPI, I2C and CAN for interfacing with sensors and other electronic devices. Quarter turning again, we discover power, flashing and reset switches, an indicator LED and an EDP interface for connecting an LCD panel. There's also this 3-pin connector whose function is not indicated in any specification I can find. On the last edge, clearly specified are a real-time clock battery connector, a front panel audio header, a front panel switch header and an EC expansion header. Finally, we have a 2-pin 12V ATX power connector, which can be used to power the board, and a 3-pin UART header. And so there we are, the Milk 5 Jupiter 2. So let's now see how it performs. Greetings! I've now put the board back in its case and got it connected up, including to this USB-C hub plugged into the main USB-C port, which is taking a power input here and an HDMI output here. And in theory, there's an operating system, Bianbu OS, pre-installed on the UFS. So all we have to do is to turn on the power. So I will do that. Here we go. Oh, I can hear a little bit of fan noise. Very quiet fan noise, but definitely some fan noise. Something is clearly happening. Very exciting. You never know what's going to happen on the first boot on really cutting edge hardware like this, but hopefully things are going to be okay. Little bit more fan noise now, and oh look, Bianbu on the screen. This is looking good, and here we are. We have to select our language, initially here in Chinese, but hopefully down here, yes, American English will do me fine. And I can now select my region. That's given me Guernsey. Can I get closer? Oh, that'll be good enough. Keyboard, I want to be English UK. And now I just need to set up a local account. There we go. And it's just checking I'm okay to proceed. I certainly am. And there we are. We just need to restart the system. This is going remarkably well, isn't it? RISC-V has progressed over the years. This is a very good initial experience, but we will speed on through as things progress. And after what was in the real world quite a long time, many minutes, rather worrying, we have got to the login screen. So hopefully I can log in. And here we are on the desktop running Bianbu OS, which describes itself as an operating system deeply optimized for RISC-V. Specifically, K3 boards run Bianbu 4, which is based on Ubuntu 26.04. Anyway, what I'm now going to do is to take a look around and apply a bit of scaling, and I'll come back to you after that. In the next part of the video, we'll run some specific benchmarks. But first, I think it's important to get a feel of whether this RISC-V system performs well enough to handle basic desktop computing. As, if it does, RISC-V has reached a point where entry-level RISC-V mini PCs and laptops are a technical possibility. If we look in Settings and About, we can see that we're running Bianbu 4.0.1, which I upgraded to using software update. Our desktop environment is LXQT, our windowing system is Wayland, and we're running Linux kernel 6.18. If we take a look in the menu, we can see what's pre-installed, and there are various standard utilities, things like disks, calculator, etc. But if we scroll down a bit, we can see that we've got the Chromium web browser, and if we scroll even further, we find that we have LibreOffice. So let's launch LibreOffice Writer. See how rapidly a word processor comes up on this system. That was pretty good. Let's type hello and select it all and make it very large, which is the law. That's certainly okay. We have a working word processor on this system. And if we return to the menu, what is below that, you cry? Well, we've also got a webcam application, a couple of media players, including VLC media player. Good to have that here. Let's just bring in a file. People always say to me, you don't play local media files, so let's play a local media file. This is an Explaining Computers trailer. This works perfectly well, as you can see, so we've got decent local media playback. And if we return to the bottom, just so I've shown you everything, not a lot more down here, but let's run up HTOP. I know some of you like to see HTOP. Here it is, running along. And over here we've got our 8 X100 cores, not very busy right now. And over on the right we have our 8 AI cores, which have got nothing to do right now, therefore they've got zero use. But I know a lot of you like to see what's happening here in HTOP, so there you are, you've had your HTOP fill. So, guess what I'm going to do now? Are you going to launch the Chromium web browser, Chris? I am. Here is the Chromium web browser with some pages preloading. We've got here the no sandbox unsupported command line flag, probably because there's been development work going on this system, but we'll get rid of that for now. I'll go across to the first tab I preloaded, which is for GPU internals, where as we can see we've got quite a lot of GPU hardware acceleration, including for video decoding, which is always good to see. So let's go across to the third tab, which is showing the WebGL aquarium, all the fishes swimming around. The refresh rate here on the system is currently 50 frames a second, which is what we're getting with 500 fish. Let's go across to 1,000 fish though. Still sticks at 50 frames a second. What about 5,000 fish? Getting quite a lot of fish there. We're still getting just over 30 frames a second, which is pretty good here in a WebGL aquarium. But guess what? We're now going to go to YouTube, specifically to the Christopher Barnett YouTube channel, where we'll find my standard test video, and we'll bring that up, make it full screen. There are no problems navigating here on the web. It's working absolutely fine. Let's just check on the resolution. We'll initially have it in 1080p. We'll bring up stats for nerds. and we have no drop frames. There are no problems here playing 1080p video. Even if I move the cursor around, make the test more difficult, no drop frames at all. But we'll also try 4K. 4K on a 1080p desktop, but we're still actually streaming the 4K media, just gives you a feel. And again, we have no drop frames. We've got very good streaming media playback on this K3 based RISC-V system. So let's come out of this like that and launch a terminal, where I'm going to do an lsblk list block devices to see the block devices of storage on the system. And guess what? We're going to test the speed of the UFS, the internal flash storage, which is SDA. So let's bring up the command for that. There we are. And I'll have to enter my password. And what are we going to get? I know what we're going to get. I've run the test already. Guess what it's going to be? 480 megabytes a second, a very respectable result for internal flash storage. So we've got a feel, I hope, of this system, and my conclusion is that K3 RISC-V hardware is capable of basic desktop computing. Right, let's now run some performance tests, starting with Geekbench. This is still in preview for RISC-V, so cannot have a license applied. But in its latest version, it should be able to take advantage of our RVA23 compliant processor. For comparison, we have this table of Geekbench scores for 3 other RISC-V SBCs, as well as an ARM-based Raspberry Pi 5 and an x86 N100 system. So let's come back to the Milk 5 Jupiter 2, where we'll run the test. And as it will take a little while, we'll now accelerate time. And there we are, it's finished, and I can smell cosily warm electronics. And because this is a preview version of Geekbench, we also need to view the results in a browser. And here we are, 342 single core and 1703 multi-core. So let's put those across onto our table, where, as we can see, it's a massive improvement over previous generation RISC-V systems, although we're not up to the performance of a Raspberry Pi 5 or an M100 PC. Next, let's go to our Chromium browser and run Silverbench. This is a browser-based CPU-only multi-core ray tracing test, and it's very important to note that it only runs properly in Chrome or a related browser like Chromium, as we're running here. And there we are, it's finished with a score of P5284, which is very exciting because if we put it across onto the table, we can see that the Milk 5 Jupiter 2 has beaten the Raspberry Pi 5. Admittedly, it's still a long way behind an M100 x86 PC, but this, I think, is a very significant result. So, for a final test, let's go back to the computer, we'll get rid of the browser, and we're going to bring up in the menu, guess what, the GNU image manipulation program, which I have installed here on this system, GIMP 3.2, and we're going to do my standard GIMP lava filter test. And as you may know, this requires us to do a new document, 1920-1080, like that. And then we'll go to filters, and we'll go down to render and lava, and bring up a clock, and then run the test. And here, we won't speed on through, this won't take very long, it's going to be a matter of seconds. And indeed, it has finished in 8.3 seconds. So let's again put the results across onto a comparative table, where, as in the first test, the Milk 5 Jupiter 2 has massively beaten previous generation RISC-V boards, but is not quite as fast as a Raspberry Pi 5 or an M100. But regardless, my own takeaway from all 3 of our benchmarks is that RISC-V performance has increased significantly on a Spacemit K3 system. Right, just a couple of final tests, and earlier I hooked up a power meter and measured about 14.4 watts at idle followed by a maximum of 20.5 watts at load when using Silverbench to max out all 8 X100 CPU cores. And the reason I ran this test earlier is that I've now installed an NVMe SSD and I wanted to run the power test before that. So let's open up a terminal and do an LSBLK just to show you the NVMe drive is there. It is, and we're now going to test its speed. Here we go. Very exciting. What are we going to get? It's a good result, I think. Yes, look at that, 2,200 megabytes a second. That's a very decent speed for an NVMe SSD on a single board computer. And the other thing I've done, if we look to the menu, is I've installed the Kdenlive video editor, which comes up pretty promptly. Come on, you can get there. There it is. Let's just do that. And I've got a quick test edit. Let's just go down to there and bring it in. Here we are, video editing in RISC-V. You'll see the timeline is scrubbable. And if I just to play the thing, it'll play the clips okay. Can it do the transition? Reasonably well. This is certainly a workable system. And I have managed to install Kdenlive on other RISC-V computers, but I've never got it to a workable state. And this clearly opens up various possibilities, including one to repeat my week doing all of my computing on RISC-V hardware, which could now include video editing. The Milk 5 Jupiter 2 is a lot more powerful than the 11 other RISC-V single-board computers I previously tested. Without doubt, its Spacemit K3 system on a chip can handle many desktop computing activities. And, according to Spacemit, it can also run 30 billion parameter large language models, so making it suitable for a range of AI applications. I therefore look forward to experimenting further with this computer in future videos, especially as software support grows. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe. And I hope to talk to you again very soon.